Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll demonstrate the use of pocket recognition to mill out all the pockets on this part, as well as drill recognition to drill out all the holes on the part itself. Since this is a large part, where the actual width of the part itself is 400 millimeters. It's being held in two machine vices as shown over here, and the stock material is shown over here around the part, and that is being held between these two parallel plates that are screwed onto the vise itself. If we take a look at our stock definition, you can see that our stock is actually this model over here, the actual stock model around the part, as shown over here. In addition, we've also defined our target, as shown over here, the part itself. And since I do have vices over here, machining vices, I've made a configuration where I show the stock as well as the vices inside the configuration. Now, I have them in separate configurations, so that it makes it a lot easier for many times to work in this particular configuration to help me pick the geometries a lot easier. So therefore, I created two separate configurations. Now, one more note is that since I do have the fixtures here itself, I've also defined my fixtures inside my machine setup. If I were to go into my machine setup, you can see I have my chamfer fixture as shown over here when I click on preview, and I also have it set exactly where I want it on the machine itself with the X, Y, and Z values. Now the first operation that I've done is to first take off the excess material that I have on top. To do that, I've used the option of face mill, and if I open up the operation that I've done over here, you can see I've used the technology of face mill. And you can see it also as well in the diagram shown here below. The geometry itself is the boundary of the part. If I have to go into my tool, you can see the tool I've chosen was a 100 millimeter face mill. And in my technology, you can see I'll be working in a hatch motion, going back and forth over the part. If we take a look at our simulation, you can see that the tool goes down and mills over the top of the face in a hatch fashion. Now, in my next operation, I'd like to start working on all the different pockets that we have over here. We have the pocket that actually goes down up until this surface over here, which is actually an open pocket going around over there as well as on that side. We also have one going over here on this side. We have this open pocket. We have this open pocket at different heights. We also have these pockets down here at the very bottom. I'd like to do them all in one operation instead of creating different geometries and different operations for heights and different types of pockets. So for that, I've used the option of pocket recognition. If I were to open up pocket recognition, let's take a look at the geometry that I have over here, or better yet, let's even create a new geometry. I'll go into pocket recognition to create a new geometry, and I'll say the following. Let's first go down to this area over here, which shows circular pockets diameter filter. For example, if we take a look at the part, this is a circular pocket as well as the hole over there. Now, if I want to ignore those areas and have it done only inside my drilling operation, I can actually filter them by giving it a specific diameter, saying anything less than the diameter written over here, do not choose that as a pocket. So if I were to click in this area and then click, say, for example, on this diameter over here, anything that is this diameter or less will not have a geometry created for that particular area. All I have to do right now is select solid body and click on the part itself. You'll note that when I click on the part, we have several different faces that were picked. In other words, every single face that's over here that has to be machined was picked, and it also learns the height of the part from these faces itself. Now, if there's a face I don't want, for example, if I were to click on this face over here, where I see that it's Z0, just click on it. You can actually see that this is a face I don't really need to do because I've already done it when I did my face mill. All I have to do in this particular case is just right click and unselect. The rest of the faces that I have here, I want to machine on. I just accept it, and that's my geometry. The rest is just like any other pocket operation. I have my tool, and if I go into my levels, you'll note that I do not have up until what depth to go, as this is given automatically from each individual pocket. If I had to go into my technology, you can see that I'll be using an open pocket, as this is automatically activated if it detects that there is an open pocket on the part itself. I'll be approaching from the outside using the profile strategy. And in the technology itself, we have our wall offset, we have our floor offset, and in this case, I'll also do a finish on my floor offset with this particular operation. Next, I also have my link, where I can use a lead in and lead out of an arc, and the places where it has to work with the entrance coming in from the top, not working from the outside, it'll use a helical approach ramping into the part itself. If I were to run my simulation on the part itself, you can see immediately that the part is being machined at each level automatically, and this is done automatically within one operation. I did not pick any levels. It picked up the levels automatically from the surfaces itself, knowing exactly how deep to go in each particular area. Working on these areas as shown over here, and in these areas shown over here, around here as well. Now in my next operation, all I have to do is finish off the walls of those pockets. So I'll do save and copy. A new operation opens up with the exact same parameters that I've had in the previous operation. And all I have to do is choose my tool. If I want a smaller tool or a different tool, I can just pick a different tool if needed. I'll select that. Again, my levels, I don't have to do anything with that. And in my technology, I'll choose the option of rest material chamfer. By choosing on rest, all I have to do in previous tool diameter is write down or choose the diameter of the previous tool that I worked with. And since I'm working here on the walls only to finish the part, I'll go into milling type and choose a round profile. This way I'll work exactly on the walls itself and not on the floors. If I were to go into my technology area, I can just change my floor offset to 0 and we're all set. Of course, I do not need the floor finish because I'm going down to 0. It's at the 0 point itself. And all I have to do right now is save and calculate. If I run my simulation, you'll see that the tool goes down in each pocket individually, finishing off the walls of every single one of those pockets. Next on this part, I'd like to drill out all of the holes as shown over here. Now, for that, in this particular case, I'm going to be using the option of drill recognition. Drill recognition is a one-tool operation that will recognize every single hole that's on the part itself and work on each hole to its proper depth from the proper height that that hole is located at. In our particular case over here, all of the holes are on the same level, so it'll have only one group. Let's take a look at the option itself. This option can be found in recognition, drill recognition. I've already created such an operation, so let's go directly into the operation itself. By opening up the operation, if I were to create a new geometry here, all I have to do in this particular case is just click on Find Holes, and it'll find every single hole that's on the part itself. Now, note that since these are all the same holes It's all broken down into one shape and into one group. There are times we can have holes with the exact same shape but with different diameters or at different heights. In this particular case, all of the holes are on the same height and of the same dimensions. Therefore, it's one group. If I were to click on shape 1, for example now, and right click on it, we have the option of show hole. By show hole, it shows us the exact shape of that particular hole. Now, if I were to go into group, right click and click on show hole, it'll show me the exact same hole, but in addition, it'll give me parameters for the group. For example, what depth that hole is going to and what is the upper level of that entire hole. Now, it's also broken down, since this hole is built with 2 different cylinders. We have our first cylinder and our second cylinder. And every single time I click on the cylinder, you see exactly what we're talking about. Over here, you can see that the first cylinder has a diameter of 23.785 millimeters and a height of 7.5 millimeters, while cylinder 2 has a diameter of 13.5 millimeters and a depth of 42.5 millimeters. Now, let's accept this and let's choose our tool. Now, in this particular case, I just want to do a spot drill, so I'll choose a 16 millimeter spot drill. My levels, note there's a safety distance, but there is no depth. The depth is figured out automatically from the height of each individual hole that we have over there. Now, since, however, I don't want to go through the very bottom of the part itself, I'd rather just give it a spot drill at this point. We have the option of depth edit. Now, the spot drill that I want to do in this particular part is a spot drill that goes actually all the way down up until the point where it can actually form a small chamfer on this edge over there. So I'll go into depth edit and I'll do the following. We have the option of drill depth. Up until what depth do I want to take the hole to? I'll click in this area over here and click on this edge over there. That's the edge, that's the depth I want to actually go to, and then I'll click on apply. Now, as I said though, I want to have it that the spot drill goes all the way down and creates a chamfer on this edge. So what I'll do is click on automatic chamfer. By clicking on automatic chamfer, it'll actually bring the tool down far enough to create a chamfer over here. Now, if I want to have a specific size chamfer, all I have to do is go into chamfer depth and say, what is the depth of the chamfer itself? If I want to have it 0.3 millimeters, I'll write down 0.3 and click on apply. We'll accept that, and let's just go directly into save and calculate. If we run our simulation, you'll note that the tool will go down to that specific height and only till that height itself. It would not go through the entire part. Now, in my next operation that I use for drill recognition, I just completed the holes themselves by drilling them all the way through the very end. The tool was a 13.5 millimeter drill, and in my level, since I want them to go all the way through to the bottom, all I did in my depth edit was to tell the tool that I want the full diameter to go to the very bottom of the hole itself. Of course, we have our technology controlling our PEC. If I were to run my simulation, you'll see that the tool goes down in every single one of the holes until it drills out every single hole, and I didn't have to tell it how deep to go. It was recognized automatically from each operation. Now, in my next operations, I wanted to finish off the counterbore of each one of those holes. So to do that, I just used a profile operation where I had my geometry as shown over here, each hole individually as shown over here, and the tool being of 10 millimeters, going down to the depth as chosen on the part itself up until the floor over there. And in my technology, all I did was use a wall offset of 0.3 millimeters as well as a finished cut. In my link, I had the tool approach with a 2mm radius, and I had the tool go down exactly in the center of the hole. In other words, start exactly from the center of each circle geometry. If I were to show this in my simulation, you'll see that each time the tool goes down, it goes down exactly in the middle of the hole itself, and then goes off to finish off each one of the circles. And it does this for each one of the counterboards that I have over here. Now, to finish off the part, I ran a chamfering operation on each one of these edges to break off the sharp burrs that may have been left here on the part itself. But note, we have this at different levels. We have it at this level over here, as well as going around the part over here. That is one level, as well as these holes here. Now, this step over here is a different level. We also have these floors that have this edge to be machined out here, as well as on the floor on this side, and these floors over here, all of them being at different heights. But not only that, in this particular case, as well as in these cases over here, the tool cannot go all the way up to the wall. It can only use part of that chain over there, as well as these areas over here. So let's just take a quick look of some of the operations I've done over here. The first one, if we just take a look at the tool pass itself, it's around every single one of those edges. And if I were to go into the operation, you can see that we're using a chamfer drill of 6mm with a 90-degree angle. In my levels, I told it I want to have a depth of 0.2mm, the depth of the chamfer itself. And if I go into my technology area, you can see we're working with the option of chamfer. And in the chamfer itself, I told it to use 1mm of the diameter of the tool, giving it an approach of a radius of 2mm with the same thing as my lead out. If I were to look at the simulation itself, you can see that the tool goes down in each one of those areas, creating a chamfer on each one of those corners over there, on each one of those edges. Now, if I were to go into my next operation, you'll see that first I'm working on these edges over here. This is the same as these over here, except this one is just lowered down. So I have it as the same as this, just with a different depth. In my next operations, as shown over here, I have these two edges over here. Now, if I were to look from the top view, you'll note that they're only starting from part of the chain itself. If we were to go into the operation itself, you'll see that I'll be working my levels from 32, which is over here itself, going down to depth of 0.2mm. Now, if I have to go into my technology field, you'll note that I have my chamfer here as well. And this time in my chamfer, again, I'll be using my diameter of 1mm. But to have this go away from this edge, not to start exactly on the edge, but away from the edge, and actually end also before the end of that edge itself, as not to gouge into the wall itself. All I have to do for that is go into my modified geometry and just tell it that I want to have it start minus 4mm from the edge and end also minus 4mm from the end of it, and have it applied to all so it works on both this and that as well. If I were to run my simulation, you'll note that the tool will go down exactly to where it has to, and it will not even touch this edge over here. It'll go in, go across, go out before it gets to the edge, and do the same thing on the other side as well. Now, on the next edges that I have to do, which was this one and this over here, this was the same case as in this edge over here, which I did just before. So all I had to do over there is, again, just make a change in my modified geometry to get to the right height that I needed to do. If I were to run now the simulation on the entire part, and I'll do it this time running the simulation of machine simulation, you can see that the part is being machined across, then each pocket within one operation of pocket recognition, every single one of them until its proper depth, and then each pocket being finished off with the pocket recognition, each hole being drilled out, each chamfer being put on exactly where I wanted it to be put, and exactly where, up until which corner and how far away from that corner I wanted it to machine. For more videos on SolidCAM Professor, please go to our website www.solidcam.com and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.